Hello, in this video I will do both reconstitution and dilution problems. Um, so if you recall, dilution is when you add more liquids, and reconstitution is when you uh, remove some liquids. So yeah, let's continue. Let's start with example one. So let's see here. Okay, in example one, we have an order of, I can't say this, I'll try my best to say this medication as I as a as I throw mycin of 500 milligrams IV daily, reconstitute with 4.8 milliliters of sterile water for a concentration of 100 milligrams per milliliter. Then dilute dose in NC to achieve a concentration of 2 milligrams per milliliters. Round your answers for C, D, and E to the nearest whole number. So I think in part A, we got to round it to the nearest tenth. So, but for only C, D, and E, round to the nearest whole number. So yeah, let me read it again. We have an order of azithromycin, 500 milligrams IV daily, reconstitute with 4.8 milliliters of sterile water for a concentration of 100 milligrams per milliliter, then dilute dose in NC to achieve a concentration of 2 milligrams per milliliter. Round your answers for C, D, and E to the nearest tens. I mean, nearest whole number. So there's a lot of going on. Let's figure out what part A is asking. So part A says, how much sterile water will be added to the vial for reconstitution? How much sterile water? So water in our case will be considered milliliters. So how they're asking you how many milliliters will be added to the vial for reconstitution. No math. So this one's a kind of trick question. There's no math needed. It kind of it kind of tells you on the problem. It says how much sterile water will be added to the vial. Um, it says on the problem it said reconstitute with 4.8 milliliters of sterile water. So that is our answer. So sometimes these problems, whoops, sometimes these problems aren't they can trick you, but sometimes the answer is just right out there. And sometimes they give you information that we don't need, like you don't need for that answer for that specific question. So in part A, it's just going to be 4.8 milliliters because that was given. Okay, let's move on to question B. So question B says, what is the concentration of the vial after reconstitution? What is the concentration of the vial after reconstitution? So concentration, this is also a no math needed. It's just part of the question. If we go back, um, it said it had a concentration of 100 milligrams per milliliter. So what is the concentration of the vial after the reconstitution? Um, it was 100 mg per milliliter. Okay, that was no math needed because that was given. So what is the concentration of the vial after reconstitution? It's 100 milligrams per milliliter. Okay, part C does require some math. Um, part C says, how many milliliters will be withdrawn from the vial to dilute with WN W slash NS? So our final unit has to be in milliliters. We can start with this problem with dimensional analysis. So with dimensional analysis, you start with what you have. But what we were given, what did we started with? We were started with azithromycin of 500 mg. So we start with 500 mg, and we're going to times this by, so I want it, it says how many milliliters, so our final has to be in milliliters. But I do have to put milligrams on the bottom because that's the only way to get rid of the milligrams. And we got to put milliliters on the top. And what is the relationship between milliliters and milligrams based on the problem? Well, they specifically said it was, so they said something about a concentration of 100 milligrams per 1 milliliters, right? Well, we're going to have to flip this because we want milliliters on the top and milligrams on the bottom. It doesn't change this, you convert, it doesn't change this concentration, right? So we could put what, we should put 1 milliliters on the top and then for 100 milligrams on the bottom. Okay. And then multiply across, so 5 times 1, 500 times 1, and then this is going to be 1 times 100. And that gives you 500 over 100, and then the zeros cancels. So you're left with 5 milliliters. And we don't round it to we don't include that, we don't say 5.0 milliliters, right? We don't include the zero. So it's going to just be 5 milliliters. Okay. Let's do the same problem using ratio and proportion. So yeah, ratio and proportion. We're asking how many milliliters, so we could put milliliters on the top, and then we also have a unit of mg. So this also has to be milliliters and mg on the bottom. So let's see. What is the relationship between milliliters and milligrams? Well, they tell us for a concentration of 100 milligrams for per milliliter. So you could put 1 milliliter on the top and then 100 milligrams on the bottom, right? And we want to know how many milliliters, so that's our unknown. And we started out, we started with 500 milligrams. We want to know how many milliliters are there for 500 milligrams. And then go ahead and cross multiply. So this is going to be 100x equals to 1 times 500. So that's 100x equals to 1 times 500 is 500. And then get rid of this x by dividing both sides by 100. And you get 5 milliliters. Okay, and then the last one we can do is we technically can use formula because our desire and have are in the same unit. So formula is desire over have times vehicle. So our desire was 500 milligrams. Our have was 100 milligrams. And our vehicle was 1 milliliter. When you put it all together, you get 5 milliliters. Thanks. So let's move on to question D. Same question, but part D. So part D says, what is the total volume needed to achieve a 2 milligrams per milliliters concentration? So the total volume means our final answer means it has to be in milliliters, right? To achieve a two milligrams per milliliter. So yeah, we're gonna use that. And for this one, I don't think we can use the formula method because our desire and have are not in the same units. So we'll start with a dimensional analyst. So we started out with 500 milligrams, and I want to get rid of that milligrams, and I want to know they're asking for a total volumes. Oops, put milligrams on the bottom, and they're asking for the total volume, so you need a milliliters on the top. They gave us they want to know to achieve a 2, so this is what they give us, 2 milligrams per 1 milliliters, right? Now, are we going to put it exactly like that? Like Here, no. We want milliliters on the top and milligrams on the bottom. So you can flip it, right? It doesn't change this concentration. So you can say for 1 milliliters, there's the same is going to give you 2 mg, 2 mg, right? So for 1 milliliters, there's 2 mg, and this has an invisible one. And as you can see, the mg disappears, and then you multiply across. So that's going to be 500 times 1, and then it's going to be 1 times 2, and you get 500 over 2, which is 250 milliliters. Okay, and then we can also do this using ratio and proportion. So that's what I'm going to do. So equal two fractions, and uh, we could put, we were given 2 milligrams per 1 milliliter, so we can leave it like that if you want. So that means we could put mg on the top and milliliters on the bottom, and then mg on the top and ml to the bottom. Blah, blah, blah. So they said that we had a concentration of 2 milligrams per 1 milliliter, and we want to know what is our final volume, total volume. So that's our unknown, and we were given 500 mg. Go ahead and cross multiply. So 1 times 500 is 500 equals 2 times x. Divide this by 2, and you get 258 milliliters. Okay, and then the last part says how much diluent should be added to achieve that concentration. How much diluent should be added to achieve that concentration? So you need to add 240 milliliters from the 5. So yeah, we we want to get 200 milliliters, and yeah, or so this is, we want to get to 250 milliliters, right? And we have to look at our previous answers. And we had, if you look at the answers for part B, how many milliliters will be drawn from the vial? 5 milliliters. So, oops. It says how much dilution should be added to achieve the concentration. So we want to get to 250 milliliters, right? But we need to add, need to add 245 milliliters from the 5 milliliters to get 200 milliliters. Okay, so you need to add 245 milliliters from the 5 milliliters to get sorry, to get not 200, 250, right? Wait, no, 200. So our goal is to get 250. We, right, our goal is to get 250, and we took out 5 milliliters, right? So subtract that from 5 and you get 245. So you're gonna have to add 245. So the correct answer is 245 milliliters, right? Remember when we reconstitute, it means you took some out, and then dilution is when you add something, right? So yeah, we want to get to 250. Um, we took out 5 because that was a we took out 5 milliliters because that was a reconstitution. So we need to add 240. 5 milliliters more, right? Okay, that's it for that part, and I'm gonna stop here.